Okay, so continuing, let's say we have this square, or sorry, this rectangle, and they're saying multiply this out, and you're like, what in the world is this? Well, you could look here, and it's 30 and 2, so that's going to be 32. 10 and 5 is 15. So you could go 32 times 15 if you feel good with your multiplication. The other way is break it apart, like they've already done here. And so 10 times 30 is 300. We got a 10 times 2 over here. 10 times 2 would be 20. And then we've got a 5 times 30 and also a 5 times 2. So, and then you add all that up and you get 480. Okay, and so next, let's say you had a super big number like 45643 times 45643. Probably not going to, but just it's the same thing over and over. So you're going to go 3 times 3, 3 times 4, 3 times 6, 3 times 5, 3 times 4, and that ends up being this long number. Then you would do this 4, which is in the tens place. Now to get there, I'd put a 0, and I'd go start all over. 4 times 3, 4 times 4, 4 times 6, 4 times 5, 4 times 4. And I'd go to the next one, which is this column. And so I'd put 2 zeros there to get me to the 6. So I'd go 6 times 3, 6 times 4, 6 times 6, 6 times 5, 6 times 4. Alright, I'd do the 5 down here. And so I'd have my 5 times 3, 5 times 4, 5 times 6, 5 times 5, 5 times 4. And it would end up going. And so I ended up doing the last. Okay, so then I just skipped all the multiplying of those numbers, but to do the very last one, let's say this 4 that is in the 10,000s place, I would put all those zeros, doom, 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 to get to this place value, and I went 4 times 3, which was 12, carry the 1. 4 times 4 is 16, plus that 1 that I carried makes 7. 4 times 6 is 24, plus the 1 that I carried is 25. 4 times 5 is 20, plus the 2 that I carried is 22. And then 4 times 4 is 16, plus the 2 that we carry is 18. You get the idea. Anyways, super big, long number. You're not going to have that, but you might as well learn how to do it now. It's just the same pattern forever and ever and ever. Okay, division, chapter 4. I got my little division guy over here, divide, multiply, subtract, bring down, and you just do it forever and ever. 6 into 7, 4, 2. So 6 into 7 is 6, and I put this first. 6 times 1 equals, it's close to 7, so 6 times 1. Okay, and then multiply, so 6 times 1 is 6. And then you subtract, 7 minus 6 equals 1. And you bring down that 4 to make it 14, and you start over. So on your little guy, after you start over, you bring it back to the top. So now I'm going to divide again. So 6 into 14. We're drawing boxes now this year. This kind of helps. So 6 into 14 is 2. And then 6 times 2 is 12. And then you subtract that, and then you bring down that 2 to make it 22, and then you divide again. So another division problem right there. 6 into 22 is 3. That ends up being 18. And then you subtract that. That's a 4. There's nothing left, so it's a remainder 4. And what do you do if you want to check? The reverse of division is multiplication. So you could go 123 times 6, which is 18, carry the 1, 13, carry the 1, and 7. So that's a 738. Uh-oh! I was supposed to get to a 742, but I didn't. How much am I off by? I'm off by 4. Oh, it's that remainder thingy. So if it was a remainder, I'm going to add that 4 to it. And so now that gets me to my 742. There it is. Good? Alright. What about like big number division? So we have this super big number, 350 million divided by 7,000. Well, what's the easy part? First, look at your 35 and your 7, right? 35 is number 7. So do that first. 35 divided by 7 is 5. Okay, we're done with that. Boom. We're done with you, done with you. So now we got all these little zeros that we got to kind of figure out. So then these, I said that these 3 zeros will cross out 3 zeros on the original. So you're like, what? So let's go back to this idea of this big number, 350 million divided by 70,000 or 7,000. So I put 5 and then count the zeros. 1, 2, 3, 4, 5, 6, 7. I have my original 7. 1, 2, 3, 4, 5, 6, 7 zeros there, right? But I was dividing by 7,000, and 7,000's got 3 zeros. So I said that these 3 zeros here, since I'm dividing, is going to cross those out. And so I'm left with this number right here, which is right there. So 50000, 50000, put your commas, and that's 50,000. So basically, this big super long number, comma, 350 million divided by 7,000 equals 50,000. Now, this one gets a little complicated, so you're like, maybe I should check this guy. And so just write your answer. You took this 7,000 times, you think your answer is 50,000. So go simple first. 7 times 5 is 35. All right, cool, I'm good. Count up your zeros. 1, 2, 3. Now you're multiplying, so you're going to put them all together. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All done. Sweet. All right, what's next? Factors and multiples and patterns. All right, your factors, 2 times 4 is 8. Factors 2 and 4, product equals 8. All right, there's just a review. Multiples of 4. So you take your 4 and then you just start counting by 4. So 4, 8, 12, 16, 20, forever and ever. Okay, so let's say there's 36 and 42. The common factors are what? Okay, so first I do the factors of 36. There's all of your division rules that we've gone over in your multiplication rules, but basically let's just do the real simple. 1 and 36, 2 and 18, 3 times 12, 4 times 9, and then 6 times 6. What about 42? Well, 42 could be 1 times 42. And notice how I go like, when I'm making this, I go 1 and 42, so small number here, big number here. 2 and 21, 3 and 14, 6 and 7. And so common factors end up being, this guy had a 1, this guy had 2s, these both had 3s. He didn't have a 4, so he had a 6. So it's 1, 2, 3, and 6. And so if they said, what's the greatest common factor? Greatest being that guy, because he's the biggest number, greatest common factor would be a 6. All right, what about prime numbers? Prime number is anything of a 1 times itself to get to it with multiplication. Example, 1 times 13. You get 13. That's it. There's no more. You can't get there, so it's prime. What about 17? 17 is like 1 times 17. That's it. What about 8? 1 times 8 or 2 times 4. Not 8. 2 times 4. So you can get there another way. And so that ends up making it composite. The coolest prime number that we've been talking about this year, cool prime number, is 2. Because it's the only even prime number in the entire world that we've found so far. All right, next. This was on your math textbook on page 214 if you wanted to relive the memories, but it was a really cool page. It goes through and it talks about how to figure out all the prime numbers. So anyways, 214. Here's 3, 6, 9, 12, 15 pattern up by 3 or multiples of 3. What about this guy? A little tougher. 3, 4, 2, 3, 1, 2, 0. You're like, what? Well, just go through and start writing down some notes. How do you go from a 3 to a 4? Oh, that's a +1. How do you go from a 4 to a 2? That's like -2. I guess you could divide by 2, but 2 to 3 is +1. Oh, maybe the pattern's starting. 3 to 1, -2. Look, hey, check it out. +1 - 2, +1 - 2. So my rule would be +1 - 2. See it? Okay, here's another one. What are the first common multiples of 3, 5, and 10? I originally said, 5 has to end in 0 and 5, right? Because 5, 10, 15, 20, and 10 has to end in 0. So I could work on the 3. And so I could do multiples of 3, but it ends up taking a long time to get to 90. So here's what I said. I think this is probably better. Work on the 10, because 10 is the biggest number. So work with him. So I said, okay, 3, 5, and 10 have to go in it. So I know my 10s are going to have to go, 10 has to go into all these numbers that I list off, 10, 20, 30, 40. I know 10 can go into those. I know 5 can go into it because 5 can go into any number that's 10. So really, I only have to focus on the 3. That's what I was originally meaning. So now just focus on your 3. Which of these numbers can the 3 go into? Can't go into 10. Can't go into 20. Can go 3 times 10 is 30, right? 3 times 10 is 30. So that guy. Can't go into 40. Can't go into 50. Could do 60, right? 3 times 20. And then can't do that. Can't do that. And then 3 times 30 is 90. So our common multiples of 3, 5, and 10 would be 30, 60, and 90. Easiest way to do it is focus on your big guy, because he's the one that's going to make things jump high, like 10, 20, 30, 40. If it was a 15, I'd go 15, 30, 45. Get the idea. All right, fractions. Oh man, fractions. Half is equal to 2/4. See, it's cut up into 2 parts out of 4, or equal to 4 parts out of 8. And I said, in real life, you won't always be given pretty pictures. So ask yourself how to get from a number to a number. So like how they get from 1/2 to 2/4. Well, you could go times 2. And I said, whatever you do to the bottom, do to the top. So times 2, times 2, times 2, times 2, times 2, times 2. You can do that forever. Okay, what about like they give you a super big fraction. They say, hey, make this smaller somehow. Well, look at your numbers, 50 and 100. Could I take a 50 out of it? Yeah, cool. So divide by 50, divide by 50. What I multiply or divide both of these by? 25 and 25. Divide by 10 and 10. And so whatever you do to the bottom, you got to do to the top. So 50 over 100. If I divide it by 10, that gets me down to 5 over 10, and I could still take 5 out of it. So 5 divided by 5 is 1, and 10 divided by 5 is 2. And that ends up getting me to a half. All right, what about common fractions? Oh, common. Compare fractions. Easiest way, if you only got 2 of them, two of them, just cross multiply. So you got 3/5 and you got 4/6. You want to see who's bigger? You got to cross upward that way. So you're going to go 5 times 4 is 20. So on this side is 20, and then 6 times 3 is 18. If you just needed to compare them, and that's all, that's it. It doesn't really help you much other than telling you how big one is in the other. Like these numbers don't mean a whole lot, but there you go. Okay, so what if they give you a whole bunch of these, like 3/5, 2/3, 1/2, 1, and 1 over 100, and they said, order it from least to greatest. I said, first thing, look for a really big or really small number. And I said 1 over 100 is super small. So that guy's done. You're like, check him off the list. Okay, so I know he's going to be super small. He's going to be at the beginning. Okay, so next I said, look for numbers bigger or smaller than 1/2. So this 3/5 popped up. I'm like, 3/5, you're kind of weird. Well, think about like AR. Like, what's half of 5 points? 2.5, right? Or 50 cents, 25 cents. Anyways, half of 5 is 2.5, and we have a 3 as a numerator. And so I said, well, 3 is bigger than half. You get that? 3 is bigger than half of 5. Half of 5 is 2.5, so 3 is a little bit bigger. So this means that 3/5 is bigger than half. But I'm not sure about 3/5 compared to 2/3, so just cross multiply those guys. Those guys are kind of like, I'm a little questionable about you guys. So cross multiply those guys. 5 times 2 is, did I mess that up? 5 times 2 is 10, not 15. 5 times 2 is 10. And so this 2/3, it's got a 10. This 3/5 is a 9. It's a little bit bigger, so 2/3 is a little bit bigger. So when I come down here and I start putting it all together, I know that 1/100th was super duper small. I then know that that half was next because he's my benchmark guy. He's my one that I kind of compare everyone else to. I know that 3/5